Okay, the next part we'll be talking about is actually finding the foot of perpendicular from a point to a plane. Okay, so same thing, it will be a lot more helpful if you actually can bother to try to draw out. Okay, so let's say this is point P, and this is my plane equation. R dot n say equal to d, d being the constant. Okay, for plane equation, we are playing with the normal as usual. Okay, and if I actually bother to draw down a straight line, okay, let's say foot of perpendicular, you are always trying to compare between the normal and the PF. So in this case, you should see that, okay, PF is actually parallel to my normal. So I have to create a line equation PF, okay? Then once I create a line equation PF, essentially finding the foot of perpendicular is just finding the intersection between the line PF and the plane. Okay, so I create a line PF first. Okay, second step, I then find the intersection between line PF and the plane. Okay, this will essentially give me the foot of perpendicular. Okay, intersection between line and plane is actually being taught previous parts under the relationship between line and plane. Okay, so if you don't remember how to find intersection between line and plane, kindly refer back to the old video to just take a quick look on how to find intersection between line and plane. If not, we are going to go through the example over here. Okay, I will go through this example with you. Okay, once you're done with this example, quickly pause the video, try doing it yourself, then refer to the answer again. Okay, this will help you to understand further and also help you to learn how to find the foot of perpendicular from point to line. Okay, so the question did say that find the coordinate of the foot of perpendicular from R from the point Q to the plane P with equation R da da da. Okay, the question did actually define for you what's your foot of perpendicular, so there's no need for me to define my foot of perpendicular. Okay, if the question did not, please remember to always define your foot of perpendicular. Okay, so same thing, I'm going to quickly draw out. This is point Q, 2, 0, 1. Okay, and this is my plane. R dot 1, 1 minus 2 equal to 3. Okay, so same thing, the question actually denote for me my foot of perpendicular to be R. Okay, so likewise, I'm going to first create line equation QR. Okay, to create a line equation, you need a point and a direction. Okay, the point you can actually use point Q, which is 2, 0, 1. Okay, the direction of the line is essentially equal to your normal. Since they are parallel, I can actually use the normal as my direction of my line. So in this case, I'm going to use lambda 1, 1 minus 2, where lambda is real number. Okay, to find the intersection between line and plane, okay, first thing first, I will say that since R lies on the line, okay, OR will then be equal to 2 plus lambda, and 1 minus 2 lambda, for some lambda is real number. Okay, once you've done that, immediately also say that R also lies on the plane. So since R also lies on plane, okay, or rather you can use plane P instead of just pi. Okay, I can say that, okay, 2 plus lambda, 1 minus 2 lambda, dot with my normal will give me 3. Since any point that lies on the plane dot with my normal will give me the constant at the back, I take OR dot with my normal, I should get 3 since R lies on the plane as well. Okay, so from here I quickly expand out. So 2 plus lambda minus 2 plus 4 lambda will be equal to 3. Okay, further solve, 6 lambda will then be equal to 3. Lambda is equal to half. Okay, so with lambda equal to half, I'm going to sub back into my OR. Okay, so OR will then be equal to 2 plus half and 1 minus 2 times half. Okay, this will give me 5 over 2. Okay, half and 0. Okay, so you can either leave it in fraction or decimal. Personally, I prefer to leave it in fraction. However, decimal is acceptable as well. Okay, take note, the question did ask for coordinate, but not the position vector. So I need to change my position vector down to coordinate form. Okay, never write from a position vector, immediately convert it to coordinate. You have to write a separate line. So in this case, R will then be equal to 5 over 2, half, and 0. This is my answer. So pause the video, okay, try redoing this question yourself without referring to the answer and see whether you can get the same answer as well.